Okay, I'm going to do it with you guys. All right. So we're going to solve this one using the quadratic formula. Okay, and that's again another way to solve this. If you remember, I did last time write out what the quadratic formula is. Okay, and we're going to use that. But in the formula, remember, there was an A, B, and C, right? The idea of the formula is you want to solve this equation that I wrote up here in red. Your A is the leading coefficient of x squared, which in this case is 2. Your B, right, is the coefficient of x. Here it's -3. You always include the minus if it's there. C, that's again the constant term. So in this case it's -5. So now we use the formula. This is the quadratic formula. Okay. You know, again, you don't have to memorize that because it's in the notes. It's also in the textbook. In fact, it's on the internet. You could just search for it. So anyway, but again, here we have B is -3. So this would be -3, which is +3. Plus or minus. We have the square root of, as you can see, -3 squared, right? -3 squared. And then we have -4 times A, which is 2 times C, -5. And on the bottom, 2 times A, which is 2 times 2. So we end up with this. This caret thing is actually an x, raising it to the second power. So this is -3 squared. And so we get 9. We have minus negative 40, which is plus 40. So we get this. So notice that we have 3 plus or minus the square root of 49, right, over 4. 49 is a perfect square. So the square root of 49 is 7, as you can see. And so we have two solutions here, right? We have 3 plus 7 over 4. That's over here. The other solution is 3 minus 7 over 4, which is also here. Okay? 3 plus 7 over 4, 3 minus 7 over 4. From here, the solution is 10 over 4, whereas here, it's -4 over 4, which is -1. Again, you don't have to simplify unless I tell you to. So if you leave it like this, that's fine. Good. Okay, so that's what we have here. Okay. Good. Okay, that's good. So that's one example. Why don't we do another one then? Let's do the last one. So here we're also going to solve this using the quadratic formula. I mean, this one might be tricky to factor, so it's actually, you'll see it's good to use the quadratic formula. Okay, so again, the whole point is you want to figure, well, first you want to make sure it's in the right form, standard form, where the right-hand side is 0. And now basically what I'm doing here, I didn't do it on the left side. Let me add that in quickly. But basically, you want to get the right-hand side 0, correct? And because you want to get the right-hand side to be 0, you want to subtract 7x and 4 from both sides. And then we get that. And so from here, we have this to solve. So we have ax squared plus bx plus c equal to 0. That's what we have here. Okay. So what's A? A is 9. B is -7. As you can see just by comparing. C is -4. That's what we have here. And so we plug into the quadratic formula, and then we solve. Doing so, we get -7 for B, which is, of course, 7. -7 squared is 49. 4 times 9 times -4, That's negative 144, so we have minus, so that becomes addition. And 9 is A, so we get over 18. And then, adding in the radicand, you get 193, so we have this. Now, it turns out 193, if you were to try and calculate that, 193 is not a perfect square. I think it's actually prime, meaning its only factors are 1 and itself. So because of that, this is our answer. So here I would probably say do not simplify, or I would just not tell you to simplify. You only have to simplify if I tell you to. Okay, so that's what we have here. All right. Okay, so that's that example. Okay. All right, so that's this one.